This is the second of two videos that you're going to watch for our lesson today. This one is over outliers, which is something a lot of people have referenced this week in different tasks that I've asked you to do. But now we're actually going to determine if the outliers truly are outliers by using a mathematical formula. You're going to notice that everybody on their page has Luca that they're talking about now, because Luca, if you notice, had a particularly rough game in his last 12 games. On one of those games, he only scored 2 points. And a lot of people are calling 2 an outlier, which it certainly seems like it is, but we're actually going to prove mathematically that it is. Just to remind ourselves what an outlier is an extreme data value that differs from the rest of the data values in the set. And by differs, that can be a really high number or a really low number. That differs from the rest of the data values in the set. So when we try and determine if something truly is an outlier, we are just going to use a formula. It's 2 simple steps, and it has to do with the IQR as well as our Q3 and our Q1. Because again, we're looking to see how far out the numbers have to be in order to be considered an outlier. So this formula to figure out something called your outlier potential, which means what are your kind of bounds when you add them to the quartiles of what your outlier potential could be. The formula for that is 1.5 multiplied by the IQR. That gives us our outlier potential, what that range is. From there, you're going to take your Q3 and you're going to add that outlier potential. And any number that's greater than or equal to that outlier potential plus Q3 is considered an outlier. We're going to take that same outlier potential and we're going to subtract it from Q1. And any number that's less than or equal to that number is also going to be considered an outlier. So I know when you look at that, it sounds kind of confusing, but when we see it in practice, it's not so bad. So let's take a look. We need to look at Luca's score of 2. We're actually figuring out if the score of 2 was truly an outlier. So let's go back and look at Luca's IQR. Some of you have this because you've been looking at his scores all week. I'm just going to scroll up on my page. It looks like Luca's IQR, our quartile 3 was 34 and our quartile 1 was 23. So this was 34 and 23. And we know that IQR is our third quartile minus our first quartile, and 34 minus 23 gives us 11. So the first thing we need to do is, again, figure out that IQR potential. So on your calculator, we're going to do 1.5 multiplied by 11. And when we do that, we get 16.5 in this case. Again, that's considered our outlier potential. Now, from here, we're going to do our Q3. We're trying to figure out the upper end, what numbers and higher would be considered outliers. So in this case, we have our Q3, which is 34. And we're going to add our outlier potential to it, which is 16.5. Okay, so 34 plus our 16.5 gives us 50.5. So are there any of his scores that are greater than 50.5? Okay, let's take a look. Nope. His maximum, it looks like, is 41. So there are no scores greater than 50.5. So there are no outliers on the high end, which we kind of expected. It definitely looks like the outlier falls on the low end. So let's find out. We're also going to take our Q1, which in this case was 23, and that should actually be a subtraction sign. That's my error. And we're going to subtract our outlier potential again of 16.5. So on your calculator, if you do 23 minus 16.5, you get 6.5. So are there any numbers less than 6.5? Yes, there are. 2 is less than 6.5, his score of 2. So since that score is less than 6.5, that indicates that the 2 is an outlier. Luca's score of 2 is an outlier. So again, just to recap, whenever you're finding outliers, you first find our outlier potential. You add that potential to Q3. You subtract that potential from Q1, and any number that's greater or less than those, that sum or that difference are considered outliers.